Greetings and welcome to Lesson 6.5, Applying Percent of Increase and Decrease. Please begin your notes by writing down the standards found at the left of your screen, upon which this lesson is based. There are two today. The first, NS 1.6, calculates the percentage of increases and decreases of a quantity. The second, NS 1.7, solve problems that involve discounts, markups, etc. You need only write down the type that is in bold. That which is not in bold is not covered in this lesson. Your notes should also include these 5 vocabulary items, beginning with percent of change found at the bottom of your screen now. Percent of change is a ratio which compares the amount of change, how much a quantity changed from one to another, compared to the original amount, then converted into percentage form. Basic ratio you will find here, amount of change over original amount. We will use this ratio over and over again. Percent of increase and percent of decrease are simply specific types of percent of change. In the first, of course, it is when the quantity increases above the amount of the original, and the percent of decrease, therefore, when the quantity decreases to an amount less than the original amount. A discount is a percent of decrease problem where the price of an item has been reduced by a percentage of the original price, giving you a new, lesser price. This is the basic idea of items found on sale at your local retailers. You will most likely have encountered this quite often. You have also encountered markup quite often, but you may not know it. The items you find for purchase have been purchased from somewhere else, a manufacturer, for a given price. The markup is a percentage of that original price called the wholesale cost. Markup amount is then added to that wholesale cost to give you the retail price that you find in the store. That markup is like a percent of increase problem. The amount is added to the amount the store paid to acquire the item to then arrive at the retail price of the item. Pause the video to continue writing down the definitions if you need more time, and I'll move on. Here is our basic ratio again. The percent of change is always the amount of change over the original amount, then converted into a percent. We can use the proportion method to set this problem up, using percent over 100 as our other ratio, and then cross-multiply and solve. Remember the basic sentence by which all percentage problems can be solved. It says the part is a percentage of the whole. Any percent of change problem, the part is the amount of change, percentage remains the same in that sentence, and the whole is the original or starting amount. By substituting out those words, we can easily take any percent of change problem and put it into this sentence form and then into the equation or proportion form. The amount of change is always calculated as a part of the original amount, never as a part of the ending amount, the new resulting amount that has been increased or decreased. Let's go ahead and attempt example 1a. find the percent of increase or decrease from the quantity 36 to 45. The first thing we'll do is find out how much did it change. What is the amount of change? In this case, and in every case, that is the difference between the two quantities. Always the bigger one minus the smaller one. We're just simply looking for the absolute value of the difference between the two. In this case, it is 9. So then, we'll set up a proportion. A proportion which always begins with the percent over 100. In this case, the percent is unknown. And the second quantity, or ratio, is the amount of change, 9, over the original amount, 36. How do you know it's the original amount? That's what it started at, as it went from 36 to 45. After you set up your proportion, reduce the ratios if possible. And I can reduce 9 over 36 to 1 over 4. Making the cross multiply and solve steps much simpler. 1 times 100, 100. 4 times n, 4n. We've cross multiplied and now we solve. Divide both sides by 4. 100 divided by 4 is 25, so n equals 25. And since this place in our proportion represents the percent, n really equals 25%. And finally, answer the question, check one last time to determine was this an increase or decrease. It went from 36 up to 45, so it increased, and this is a 25% increase. Remember, if you need more time to record the steps of the flow map or complete the problem, you can always pause the video. I will move on. Example 1b. Find the percent of increase or decrease from 55 to 44. We will repeat the same steps again. I'll go rather quickly this time. First, how much did it change? The difference between 55 and 44 is 11. So we can use that to set up our proportion. It's always the percent over 100. Again, the percent is unknown. What the problem is asking for is the percent. And the other ratio is 11 over 55, because 55 is what it started as. Let's go ahead and reduce this ratio before we continue to solve it. We can divide 11 and 55 both by 11, reducing this to 1 over 5, a much simpler ratio to use in our solution. Next, cross multiply and solve. 100 equals 5n, divide both sides by 5, and n equals 20. And again, that n is holding the place of a percentage, so n equals 20%. Check back at your original problem. Was this an increase or decrease? The quantity decreased from 55 to 44 by a total of 11, which represents a 20% decrease. Oops. Pardon me. Copy paste. Defeated me, but I will overcome. This is a 20% decrease. There we are. Moving on. Now, in example 3a, we are given this information, that an admission ticket to a museum costs $8, but students receive a 15% discount. So, how much do students pay? Discount is a percent of decrease problem, because the students will pay a reduced amount, a bit less than the $8 that other patrons shall pay. We first need to find out how much that discount is before we can find out how much the students will pay. The discount is the amount that is deducted from the $8 normal price. So let's find the discount amount. We can do that by setting up a proportion, filling in the information we do know, and using a variable to represent the amount we don't. In this case, that's the amount of the discount. We know that the discount percentage is 15. And the discount amount is unknown, but it is 15% of the original price, $8. We are using the same flow map as in the previous examples, the next step in which is to reduce. However, when my unknown is here, and I'm going to multiply it by 100, later on I'm going to be dividing by 100. Dividing by 100 is very easy. If I were to reduce this problem to 3/20ths, I then have to divide by 20. It's not rocket surgery, but dividing by 100 is easier. So in this case, I am not going to reduce, and know that that option exists. You do not always have to reduce the ratio before you solve the proportion. So I'm skipping the reduce step, moving right along to cross multiply and solve. 100x equals 8 times 15, which is 120. Divide both sides by 100. And remember, dividing by 100 is as easy as taking 120 and moving the decimal over 2 places. 1.20, which is $1.20. That is the discount amount. Keep in mind that the discount dollar amount is what is taken away from the original price. So subtract the discount amount from the original price, and we get a total of $6.80. If you are at all confused by the way I solved this problem, take a look at your book. They offer you 2 alternative methods for calculating the discount amount and the final price. I prefer this method, but I am happy to assist you in using another method that you find more clear. Let's move on to example 3b. Example 3b refers to an amount of markup. The problem is essentially done the same way. Markup is a percent of increase instead of decrease. So in this case, we have a wholesale price, which is what Caleb purchases the necklaces for before selling them to someone else. He needs to sell it for more than what he paid in order to make a profit, in order to benefit from the sale. We need to find out how much he sells it for if his markup is 75%. So this time we need to find the markup amount because we know the percent markup, it's given here, 75%. We know the original price. The wholesale price is $48. What we don't know is the amount of markup. Let's find that just as we found the amount of discount by setting up a proportion. Oops, I'm ahead of myself. I don't want to reduce yet. I have nothing yet to reduce. The percentage is 75 over 100. The amount of markup we do not know. I like X. You may prefer another letter, but keep in mind that I am a professional. I've covered it up there, but the wholesale price was $48, the original amount. 48. There we are. Now I can reduce. And in this case I'd like to reduce because multiplying 75 times 48 won't be so fun. So I'll reduce it because 75 over 100 divides by 25 and it's 3 over 4. Now 3 times 48 is 120 plus 24, that's 144, and 4 times x is 4x. Oh, now I'm ahead of myself in the other way. I've cross multiplied, and let's solve. Divide both sides by 4, and x equals 36. Always check back and see, what was that x holding the place of? In this case, that was the amount of markup. So 36 is the amount of markup. The markup is $36. Caleb adds $36 to the price that he paid before he sells them to someone else. So we add those two together. What he paid plus the markup, we get a total of $84. You may find this astounding, but many of the things that you buy in the store are marked up by more than 100%. The retailers are keeping more than half of the money you spend on the items. I've asked that you answer this one think and discuss question before moving on to the practice exercises. For those of you who are bothering to listen to me ramble, I will answer it aloud for you. When finding a 20% increase of a number, you are taking that number, let's say, for example, 50, and increasing it by 20%. 20% of 50 is 10. So a 20% increase from 50 results in 60. If you were to find 120% of 50, that would be like multiplying 1.2 times 50. I'll do the math for you. That equals 60. So a 20% increase takes the original number and adds 20%. A 120% calculation of a number, the 100% takes care of the number you started with, and the 20% adds on the additional 20%. So they are essentially the same thing. Here we go. I've got the flow maps set up to go along with each of these. I'll say very little as I work them out. For % of increase or decrease, always ask how much did it change from 40 to 59. That is a change of 19. So set up a proportion where the amount of change is on top, the original amount 40 is on the bottom, and we are trying to determine what percentage that is. Reduce if possible. I cannot, so I move on, cross multiply and solve. 1900 equals 40x. Solve, divide both sides by 40, and x equals, well, that's not exactly a slice of rhubarb pie. Let's see. I can take off the zeros, reducing it by 10. I've got 190 divided by 4. I'll go ahead and do it longhand here so you can check your work. Do not use a calculator. There we have it. 47.5. Remember, this is a percent, so it is an increase from 40 to 59 of 47.5%. Next, number 3. Same type of problem. It happens to be an increase. I can see it goes from 85 to 170. How much did it change? Well, the difference between 170 and 85 is 85. So take a look at this. Set up your proportion. We want to know what percent that is, x over 100. The amount of change, 85, over the original amount, 85. How much, what percent is 85 of 85? I'll solve it so you can see, but let's reduce. I can divide 85 and 85 by 85. reduces to 1 over 1. What percent is 1 of 1? It is the whole thing. Let's continue solving. Cross multiply. 100 times 1 is 100. 100 times, x times 1 is 1x. Divide both sides by 1. This is highly unnecessary, but nevertheless, x equals 100. X is a percent. So this is a 100% increase. When a number doubles, it increases by 100% because you take 100% of the original amount and add it on. Now you have 200% of the original number, or you have the number you started with plus 100% more, a 100% increase. Alright, on to the last problem. Remember, this reference here says you can go back and look at example 3, which I have worked out, which is worked out in your book, to see how to do it. Alright. An automobile dealer agrees to reduce the price, so we have a percent of decrease or a discount, by 5% for the customer. What is the discounted price of the car? Well, we need to find the discount amount. The discount amount is calculated by using the percentage given. It's 5%. The discount amount is what we don't know, but the original amount we do, which is 10,288. That's a terrible looking 8. Let me fix it. We've set up our proportion. Let's reduce if possible, yes. Let's divide that by 5, that's 1, and that's 20. Now you can decide, it might be easier for me to divide that by 20, it might be easier for you to multiply it by 5 and then divide it by 100. It's up to you. Alright, reduce it or not. Next you must cross multiply and solve. 20x equals 10,288. Divide both sides by 20. And x equals, here we go. I got to do this longhand again, okay. So, 20 goes into 10,288. I'll stop mumbling while I work. The decimal is right here in the beginning number, so it moves right up above it in the answer, and that would be 0.4. So x equals 514.4. Now recall that this is a discount amount. It's in dollars. So if there's numbers after the decimals, those are cents. And it's 0.4 with nothing after that, so that's $514.40. That is the discount amount. The discount amount is what is subtracted from the original price. So we do 10,288 minus 514.40. Remember, if you're dividing or subtracting and you have missing spots above, after you line up your decimals, fill them in with zeros. There's our discounted amount, $9,773.60. That's how much the customer will pay for the car. Well, thank you very much for tuning in. I hope you have a wonderful evening, and I will see you tomorrow.